Hey, hi guys, in this video I'm going to explain what actually the electromagnetic spectrum is. The electromagnetic spectrum is the entire range of all possible frequencies of electromagnetic radiation. In remote sensing, when the light is generated from the source, it travels toward the surface of the earth and it strikes on the surface of the object that is present on the surface of the earth, and it reflected back to the sensor, and the sensor measures the energy of the light in energy of the electromagnetic radiation that is reflected from the surface, and it's sent to the analytical stations, and the analytical data is used for the applications. And when the light is generated from the source, it travels toward the surface of the earth in the form of electromagnetic radiation, right? And you can consider that the light is generated from the sun in the passive remote sensing, and the sunlight is called the electromagnetic radiation, right? And all the possible frequency of the electromagnetic radiation is called the electromagnetic spectrum. And you can also visualize the electromagnetic radiation and more clarify the concept of the electromagnetic spectrum by it's like a bundle of the light ray, right? This light is made from all of the lights, right? It's a gamma ray, here is a gamma ray, here is a x-ray, here is ultraviolet ray, here is a visible ray, there is a near infrared, far infrared, microwave, and then the x-ray. And this light is composed of all these light, all of these lights. So all the possible frequency of this electromagnetic radiation is called the electromagnetic spectrum, right? The electromagnetic spectrum is ranges from, okay, from the radio wave to the gamma rays. I am writing from here you can see the wavelength is highest of the radio wave, and the energy is lowest of the radio wave, and the frequency is highest in the gamma ray, wavelength lowest, and the energy is highest. And I'm writing from the gamma rays toward the radio wave. Okay, there is a gamma ray, there is a gamma ray, there is a x-ray, and there is a ultraviolet ray. Here comes the visible light, there is RGB or VIBGYOR, anything you can say. I am only saying the RGB because these are the primary colors. And after that we have the infrared. There is infrared is divided into the near infrared and mid-wave infrared and the far infrared, right? And then is a thermal bands, thermal infrared, and then we come to the microwave, and then it is called the radio wave. And in the remote sensing, we all of the portion that is beyond the ultraviolet is absorbed into the atmosphere, and some part of the near infrared is also blocked into the atmosphere, and the visible light is coming to the earth, and some part of the near NIR is coming to the earth, microwave is coming to earth, and also the radio wave. But here in remote sensing we use from the near ultraviolet ray, from the ultraviolet ray, or more possibly from the blue light to the microwave. And all of the optical remote sensing use the light ray from visible to the thermal bands, while the SAR imagery use the microwave portion of the electromagnetic spectrum. Okay, and you can see here this is the RGB image of the field. And if we see the NDVI value, NDVI is nothing but it is the secondary product that is derived from the near infrared. NIR minus R upon NIR plus R. Okay, and one thing is NDVI highlighted the area where the NDVI value is highest, and you can compare the RGB value and the SAR data set of the same region, and this is the thermal band, this is the RGB band. So each of the electromagnetic radiation have their own specific application in their own area. So we are using the different bands based on our purpose. Okay, and you can see here from the gamma ray, X-ray, ultraviolet, infrared, microwave, and the radio wave range of the electromagnetic radiation. Okay, and okay, we are using from only the from the ultraviolet to the microwave in the remote sensing. So we are only discuss this topic only: ultraviolet, visible, infrared, and the microwave. And okay, the first one is the ultraviolet or the UV portion of the electromagnetic. For mass purpose, the ultraviolet or the UV portion of the electromagnetic spectrum has the shortest wavelength, which are practical for the remote sensing. All of the electromagnetic radiation beyond the ultraviolet radiation is blocked by the atmosphere, so we can't use gamma ray and X-ray and most part of the ultraviolet ray in the remote sensing. So we can design to measures the radiation that is reflected from the gamma ray and the X-ray. Okay, the radiation is just behind the violet portion of the visible wavelength, hence its name. Some earth surface material, mainly rocks and the minerals, fluoresce or emit the visible light when illuminated by the UV radiation. Okay, and then we come to the second, we come to the visible spectrum. Yeah, we all know that BI visible, indigo, blue, green, yellow, orange, red, right? And you can see all of the visible portion is made from all of these radiations, and each of them had their own application. So but in most of the remote sensing we can only see the blue portion, green portion, and the red portion here, red portion. And then after we come to the infrared here, and the next portion of the spectrum interest is the infrared region, which cover the wavelength range approximately from 0.7 micrometer to 100 micrometers, which is more than the 10 times wide edge visible portion, right? The infrared region can be divided into two categories based on their radiation properties: the reflected infrared and the emitted or the thermal infrared. The reflected infrared cover the wavelength from approximately 0.7 micrometer to 3 micrometers, is used for the remote sensing purpose in ways similar to the radiation in the visible spectrum, right? The reflected infrared is used is same type is visible spectrum, but the thermal infrared is essentially due to the radiation that is emitted from the earth. The thermal portion is doesn't while the radiation is coming to the earth, some part is reflected, and this is called the reflected infrared, and the sum of the portion is emitted at the night. When the light is absorbed into the daytime, the object get heated, and the radiation is emitted at the night time. So this portion of the electromagnetic radiation is called the thermal infrared, and we use differently than the reflected portion, right, and from the earth. So the surface in the form of heat. The thermal infrared covers wavelength from approximately 3 micrometer to 100 micrometers. And then next we come to the microwave portion of the electromagnetic radiation. Here the hot topic is SAR imagery, synthetic aperture radar, and the synthetic aperture radar use the microwave portion of the electromagnetic radiation. It is the topic of the research in the recent time because the SAR it doesn't block by any of the clouds, and it is operated into the also into the different weather condition. So the microwave portion of the electromagnetic radiation is the most research topic in this most hot topic or the research topic in the today's world. The portion of the spectrum of more recent interest to the remote sensing is the microwave region from 1 millimeter to 1 meter wavelength. This covers the longest wavelength used for the remote sensing. This is the longest wavelength into the that is used in the remote sensing. If we see the electromagnetic spectrum here, you can also see the radio wave is also has the large wavelength than the infrared, larger than the microwave, but in the remote sensing we are only using up to the microwave portion of the electromagnetic radiation, because as the wavelength get increases, the energy is decreases, so we can detect the energy that is reflected in the form of radio waves. So the microwave portion of the electromagnetic radiation is the longest wavelength that is used in the remote sensing. The shorter wavelength have the properties similar to the thermal infrared region. Okay, you can see here. Okay, let me go to the electromagnetic spectrum curve. The shorter portion of the electromagnetic radiation, the microwave portion, is resembles with the thermal infrared. Thermal infrared, while the longer wavelength approach to the wavelength used for the radio, and the much longer wavelength that is resembles with the radio portion here. And most of the radiation used in the remote sensing is lies in this part, center part. There are the lots of the different bands of the microwave. They are K, Ka, Ku, C, S, L, P. These are the different bands that is used in the microwave remote sensing. That is all for the electromagnetic spectrum. See you in the next video. Thank you.